both.
Action.
We're 22, 8 through 12. Off we go. 1 is a thing called a voltmeter. 2 is a thing called an ammeter, A-M-M-E-T-E-R. 3, 4, I decided to count as 1 extra credit point. So if you have 2 things, good for you. If you have 1 thing, we're okay. So a true perfect paper will be out of 31, but I'll count the score out of 29. So the answers I was hunting in the end are to either change the voltage or to change the resistance. But the book expanded on ways that you could do that. So if instead of changing the resistance, they got into a thing called control resistors or variable resistors or heat, that would all be fine. New equation for electric power, P equals I squared R. The equation for heat energy is delta Q equals I squared RT. 7, 8, I did the same thing as with 3 and 4. If you have 1 answer, I'm good with you. If you have a couple answers, I'll give you extra credit. So the answer I had in mind was low resistance. Another answer I had in mind is low current. But if you decided instead of low current to say high voltage, that's true. If instead of low resistance you said to use a good conductor or to use a large diameter cable, those are ways that you can lower resistance, and those are wins as well. So if you have 2 wins, there's bonus point for you.
Wait, so are we only looking for 1 for those though?
You only need 1.
Okay.
But if
But
you
if they
have
have
2,
two,
then
then
it's a
that's a
bonus.
bonus.
Yeah.
Okay.
9's a kilowatt hour, or kWh if you like abbreviations. And then we're into the old questions at that point. Anybody top 9 question about scoring something? 9 is a kilowatt hour. kWh. Thing there? Then old ones. 10 is transfer energy. 11 is from high concentration to low. 12 is the work to move 1 coulomb between 2 points, or work to move a unit charge between 2 points. 13 is volts. 14 is joules per coulomb. 15 V equals ED. 16 there's electric versus gravitational. Electric is work to separate charges. Gravitational is work to lift it. And then there's choices for the differences. Most people were picking gravitational as attractive, whereas electric can attract or repel. But there are other differences. Does anybody need me to say the other differences? I'll say them anyway, just because we're recording this time. Gravitational, you could also say, is the same everywhere. Electric, say it depends on the charge intensity of the plates. The last difference is gravitational potential difference is measured with joules per kilogram, whereas electric is joules per coulomb, because in the future, who knows what people may pick. The equation for work is W equals VQ. Work is stored as potential energy. 24, current is flow of electrons. 25, generators move, pump, send electrons from a positive to a negative plate or area or something. 26 is amperes or amps. 27 is a coulomb per second. The other equation for power, P equals VI. Resistance is the ratio of V to I, or ratio of potential difference to current. Unit is ohm, OHM, or you could draw that omega horseshoe looking symbol. And then the equation for Ohm's law is I equals V over R. Question about scoring the bottom. So let's go back to the top and check notes. Homework tonight is going to run 24 to 34. 2 days away, we'd have a chapter review come due. 3 days away, we'd have the practice test come due. So that's our assignments. 24 to 34, chapter review, practice test, the next 3. Tomorrow quiz, we would take the quiz that's titled 22, 8 to 12, Part B, which should match the vocab practice test. Does vocab practice test go to 44?
Yes.
How many joules is it for 44 and then it ends?
Yeah.
Yep, so that 44, that'll be the thing, the quiz for tomorrow. And right now I'll tell you some things that'll help you fill in some of the blanks on that. Question,
So-
where we sit, yeah.
Wait, what are we counting this out of again?
It's 31 is a true perfect paper,
Okay.
but when I do the computer, it'll be out of 29. But
29.
you can just do the math like from 31 if you want.
Yeah, okay.
Question about scoring that thing? Okay, so here's notes on my 8 to 12 that probably predict the changes for the practice testing. Voltmeters are always connected in parallel, and I'll explain what that means in a second. There's a chance that that's a quiz question maybe. Ammeters always get connected in series, and I'll explain what that means in a little bit. Yeah, those are new questions. I see those coming. For sure, you're going to have to draw the diagram that's over my shoulder. So here's the diagram over my shoulder. It'll say, draw a diagram of an electric circuit, voila, that labels a battery. Can anybody spot which part of this is the battery? It's the bottom thing because batteries are like volts and stuff. But batteries go long, short, long, short, long, short. The long side's the positive side, the short side's the negative side. So there's a battery. You don't have to put a number on yours. I put a battery on mine just for the heck of it. It'll say label a resistance. Can somebody spot the resistance?
It's 15.
It's the 15. It's this zigzaggedy thing. There's always this like zigzaggedy thing to represent resistances. Basically, this would be like you turned on a light, you turned on a can opener, you turned on some appliance that's plugged into your electric circuit and electricity flowed through it. But the resistances, the things you turned on, those are going to be these little like rough zigzaggedy things. It'll tell you to label an ammeter. The ammeter I said a second ago is connected in what? In series. In series means it's like connected right into the line, that like the line runs straight through it. So it's connected in series. Voltmeter was connected in parallel. That means they like clipped a new path around it. So the electrons were running in this path. To be connected in parallel means you clip on to one side, you clip onto the other side and create a new path that the electricity could flow. So a voltmeter gets connected in parallel. Then I already said this accidentally, but who's making the moves? Protons, neutrons, electrons, who travels? Electrons travel. So they're going to throw some arrows on here to show direction, because the arrows would be wanted to head where compared to the negative end? Run toward or away from the negatives? Run away, because like charges repel, which means it would want to run toward the positive side because like attract. But they're going to be running some stuff in some loops like that. Question about the picture. Other notes, 3 and 4, the double answers that you probably need both next time were to change the voltage or to change the current, or change the resistance, excuse me. Change the voltage or change the resistance. And then ways you can change the resistance, I made a side note that you probably need to know. There's a thing called control resistors, there's another thing called variable resistors, and then heat as well. When things heat up, it changes the resistance of the circuit. So control resistors, variable resistors, heat, you probably need to know. The equation for power probably stays the same, the heat thing probably stays the same, but let's explain what the letters are for. Maybe jot those down, but not for quiz purposes, but homework purposes. P stands for power. What's power measured with? Watts. I stands for amperes, current. R for, we'll keep talking for a minute, resistance, which is ohms. The Q thing is an energy, so that's joules. The T thing in the next equation, that's a time. Rattle off a couple more notes and then we'll run for the hills. 7 and 8, we were looking for low resistance and low current. But follow up to how you can do low resistance is either a good conductor or a large diameter cable. You probably need that. Low current, follow up is high voltage. You probably need that. And then the last side note is kilowatt hours. A kilowatt hour is 3.6 times 10 to the 6 joules, and I definitely see that on the quiz. 3.6 times 10 to the 6 joules makes a kilowatt hour. That's what you pay for when you're a grown-up with an electric bill. they'll tell you how many kilowatt hours you use. And it's usually not a lot, might be like 50, 100, whatever, it's like a countable number. They never bill you for joules because it would be like millions and millions and millions and tens of millions of joules. That'd be a crazy way to bill. But kilowatt hours, and then we'll shut that down, and that's that.
Hi.